So this lab will be over the common ion effect, and we will be using a virtual lab called Chem Collective. So before we go into how we're actually going to complete this lab and how Chem Collective works, I do want to briefly touch on the concepts that we're using in order to do this lab, and also it'll kind of help you give a visual on exactly what's going on, especially at kind of the ion level. So we learned about sparingly soluble compounds, and this was part of chapter 15, and that was finally the last chapter on equilibrium. So in that chapter we learned about sparingly soluble compounds, which are insoluble compounds. So I have these quotes on it because you learned about insoluble compounds in Chem 1, and in Chem 1 we kind of just learned the solubility rules and how these compounds just do not dissolve in water, right? But they actually do dissociate, in other words, dissolve. Dissociate actually means for like the ions to come apart. So let's say, for example, this is actually a soluble compound, but if we were trying to look at a compound dissociating, this would turn into the ions. So Na plus and chloride. And I didn't write the states and everything, but that's what we mean by dissociate, to turn into the ions or to come apart. So insoluble compounds actually do dissociate to a very small extent, and that's why we say they're sparingly soluble, so not as much compared to a soluble compound, but a very small amount can dissociate. The equilibrium constant of the ions that dissociate off can be determined and is actually called KSP. You'll also hear this called the solubility product. For me, I just like to keep it short. I'll just say KSP. And here I have an example. So this is solid AgCl. I don't have the state right here, but basically it's a solid. And you can see here it's the little cube that's sitting there. And when you first put it in water, it's not dissociating just yet. But if you give it some time for it to reach equilibrium, what you will see is that you will have the ions dissociate, a few of them, not the entire thing. You're still going to see a good chunk just sitting there, but a few ions do dissociate off. And that is how we can determine an overall solubility product for this. So for example, here it'll be the Ag plus and the chloride, so silver and chloride ions, and these are the colors for them, so the gray ones are the silver. So KSP, solubility product, is an equilibrium constant. It just happens to be very specific for these types of compounds that are sparingly soluble. And if we were to write it out, we can see that it's the ions, and we don't include the solid that we started off with, in other words, our reactant. We don't include that because it's a solid, and we don't include solids or liquids in our equilibrium constants. So this is just an equilibrium constant, except it's a little bit special. It has a special name. The same way how Kas for acids, we call them Kas versus Kcs because it's specifically for an acid. So it's a similar idea here for our solubility product. So a major idea that we learned in that first equilibrium chapter, the one before acids, which was chapter 13, we learned about how systems at equilibrium can be shifted. So they can be shifted by either adding more product, adding more reactant, whatever it is. Now for these particular systems, these sparingly soluble compounds at equilibrium with their ions dissociating off, we only have our products, right? We only have our two ions. If you add more of the solid, it won't affect the overall equilibrium constant, but if you add more of either one of these two ions, it will affect one of the two concentrations. So if we introduce one of the ions that is part of the KSP expression, this will cause a shift. This is actually called the common ion effect. So if we add either chloride or if we add silver, this will cause a shift, and that is called the common ion effect. So in this particular lab, we are actually going to be introducing NaCl, or actually we can look at it the other way. We are going to have a solution that contains free NaCl ions, and we are going to have we're going to add AgCl solid. So what we're going to have in solution is a solution that has a bunch of sodium and chloride ions, sodium, and just imagine that there's like a bunch in there. Imagine, obviously a lot. This is not to scale, but this solution already contains it. This is our unknown. We are going to add in solid AgCl. When we add this in, because we have that common ion already in there, the chloride, I'm going to color it in, that common ion will cause a shift. So overall, we're going to have more of that chloride. Oh, I should have colored it green. But we're going to have more of that chloride, right? So that is going to cause a shift in however much ion we have in solution. So it's kind of a different situation where we have the common ion already in solution, the chloride, and then we add in the AgCl, let it reach equilibrium, and then measure the Ag concentration. So we're going to introduce silver chloride to the solution and measure the silver concentration. Measuring the silver concentration will allow us to determine the concentration of chloride. So our KSP is going to be given. We have this. We are going to measure this with our Chem Collective virtual lab. It's going to measure it for you. You just have to record it. And then what we're going to calculate is this right here, the chloride ion concentration. So you can kind of see here how we would solve for this. You would just do algebra and solve for the chloride ion. This KSP and the KSP is constant. I give it to you in the lab, so that's like a known, a constant. This right here will be you'll record it from the lab, and basically what we have here is an inverse relationship. So for KSPs, the number stays the same. If one of these goes up, so let's say for example Ag, the concentration goes down, that means that this one went up. And that's what's happening when you introduce chloride to this particular situation. If you have AgCl reaching equilibrium where its ions are in solution, and then suddenly you have a lot of chloride, this Ag is going to decrease in order to keep that KSP value constant. So that's why we're calculating based off of the Ag concentration. So for the procedure, I'm actually going to take you through a screen capture of me loading up this lab. So I loaded up the link on a browser and, make sure it's the correct one. It gives you like this little intro paragraph. And then down here, you have your little workbench area. And right here is where you can bring over whatever you need. So I brought over my scale, I brought over a weighing boat, and then I also brought over my unknown NaCl solution. Something else I need to bring over is my silver chloride. I'm going to rename by right-clicking that unknown NaCl. I'm going to rename it to trial 1. And something you should note is what I'm hovering over right here, which is the volume of this unknown NaCl. So you should record this volume before you've added anything. Next, what I'm doing is I'm taking the weighing boat, putting it on the scale, and I'm attempting to tear the scale. Now, sometimes with this website, it's a little glitchy and it'll like not tear, so you just end up having to bring another scale. And yeah, that kind of sucks, but I mean, the website's free and everything, so it's the best we can do. So I was trying to tear, and then I had to pause and like just restart it, like re-bring another scale until it finally did it. So I teared it, and now what I'm going to do is bring my AgCl, my silver chloride, and I'm going to weigh out what I need, which is 5 grams for my trial one, and then you pour it. And then what you're going to do is bring it over, drag it on top of the trial one solution, and press realistic, and then pour it out. And it all poured out into here. I know you can't see it actually in there, but there's silver chloride solid in there, in that solution. Now it's reached equilibrium, like pretend that it reached equilibrium, that it was a little bit of a while. And what you can see more information of this solution. And the information that's important is the molarity of our Ag ion. So this amount right here is the molarity of the Ag, of the silver ion. And it also tells you how much silver chloride you have in there. So I know this is, it's if you haven't really captured the idea here yet, but sparingly soluble compounds, they kind of leach off a little bit of ions, but it's a very small amount. So look at this number. It's 1.87 times 10 to the negative 10th. It's a very small number. So even though right here it says 5.0000, right, of our solid, a little tiny amount of our Ag did come off into solution. That's why it has a molarity. So that's going to be one of the measurements you take. So read through the procedure, and that's one of the ones. The other one was that volume before we added our 5 grams of silver chloride. This volume right here is once you've already added those 5 grams. So that volume has been adjusted. That's not the volume you want. You want it before. So you're going to repeat this entire process by bringing over from the stockroom 2 more sets of unknown solutions. You're going to rename them trial 2 and 3 just so that you don't get them confused. If you want, you can right click this one, the trial 1, and remove it just to get it out of the way and have like a clean workbench. It's up to you, but don't worry, like if you mess up on the first time or something, all you have to do is reload the entire page and you just start over. It's not a big deal. But make sure that if you reload, that you start over with your data, you collect new data, because it generates a random concentration each time. So I mentioned this during the procedure video, the little screen capture, but you're going to be recording the volume of your unknown NaCl for each trial. I have a table where you're filling that in. You're going to record the mass of AgCl added for each trial. That is stated on the procedure. It tells you how much to add for each trial. And then you're going to record the molarity of the silver ion after the addition of our silver chloride after it has reached equilibrium. So you just click on the information tab. After this, so this is like the data you collect, and then this is the data that you're going to calculate. So first you're going to calculate the chloride concentration by using these two like expressions slash values. So you have this value that's given, and then you have this expression, and I'll leave it up to you. You're going to do a little bit of algebra and solve for chloride. After you determine your chloride, you will use that to determine the concentration of NaCl. So I do want to see this written out, like on your work. I know you're probably like, oh, that's simple. Why do I need to show that? Please show it. And just show me that you understand that there's a stoichiometric ratio to that. If you have any questions about that, let me know. And then finally, you will take those moles. You're going to first determine the concentration of chloride, and then determine the concentration of sodium chloride, and then use that concentration to get the mass of your sodium chloride. So you'll use the molar mass. And also in there, in order to get concentration in grams, you will have to multiply by that original volume you recorded. So each piece of data that I have you record is important, especially that volume of your unknown NaCl, and also the concentration of the silver ion that you're recording, this one. And then finally we have the applied exercises. These are just meant for you to kind of reflect on what you just calculated, overall what a KSP is, a solubility product, And these also will help you when you write your lab report. And the reason they'll help you is because they are kind of like STEM questions. Like they're the stem of it. They'll get you going with that discussion. So if you have some good answers here, then you pretty much have some of your discussion already done for whenever you write your lab report. I haven't posted the lab report video just yet, like the instructions and everything, but I will be posting it and it will be over the slab, so that's why I'm saying that, FYI. There will be an announcement on that, so don't worry. Like if you didn't know that already, that's because I haven't formally announced it. But if you're watching this video ahead of time, then you'll know at least. So just make sure to answer these in 3 to 4 complete sentences. You know, you can use the book to help you answer some of these things like KSP, like what the definition is and things like that. If you have any questions, just let me know. Just email me.